It's the concatenation of KRs. So it would be R concatenated R, and so on. Okay, so that this set, once you evaluate it, it would be the set of all concatenations where each concatenation has resulted from K concatenations. In other words, you have K strings in a row in your concatenated string. Right? So you take your R, that's your language of strings, set of strings, and then you form a concatenated string from K of these strings of R. Right. Okay. Now we've been sort of mixing. It's been a bit confusing. R. Sometimes we look on R as a regular expression, hence big R. Sometimes we look on it as a language of strings. It's a bit confusing. So if you really want to be clear that you're talking about the regular expression, that would be R. But if you want to talk about the language the regular expression describes, well, you tend to write it this way, like L of R. Okay? So that would mean the language that R describes. So now language is just a set of strings, right? So you could describe L of R as like wiggly bracket W. W just stands for a string, and then vertical bar. In other words, such that, or having the property that, the property description of a set, and then you list the property that W has, and we'll do quite a bit of that. Down here. Here, yeah. Okay, right? So, so if you want to distinguish between R, the regular expression, and R, the language, you make it explicit that you're talking about the language of R. Well, then you write it this way: L of R, L parentheses R, like this. Right? So if you see that, you're talking about the language that R describes. Right? Now here's some examples. Example 1.53. Sorry, you can't see it. Previous session we had definition 1.52. So that was consecutive. And then prior to that we had example 1.51. Okay, so Sipser is using global ordering, as I call it. All right. So now we'll do some examples. How to, manipulating, writing regular expressions and so forth. Give us some practice on how to do that. How to write out and interpret various. Asking yourself, well, what does that expression mean? What is its language? So, in a sense, we're giving examples now. On the left-hand side, so we've got 5 examples. On the left-hand side, you have a regular expression, okay, and on the right-hand side is its corresponding language. So left-hand side, that would be your R's, and the right-hand side, that would be your L of R's. Okay, all right. Well, let's have a bit of fun. What language is this regular expression describing? Okay, have a look at it. Try not to cheat. Just look at the left-hand side without, if that's possible, without looking at the right-hand side. It's sort of like me asking you, don't think about an elephant, okay? That's a common joke for native English speakers. All right. Okay. So what's the language description of this regular expression here? So you can have any number of zeros in front of the 1 and then a 1. Now remember, implicit, either side of the 1 is a little circle concatenation, but this is the shorthand notation. We're writing it in shorthand. So so you can concatenate with a 1, and then you concatenate with a set that well, 0 star, so it could be 0 or any number of concatenated zeros in each string. So the language this describes is just all possible binary strings that have only one, or a single one in it. Does that sort of seem plausible? So, you know, the language of this is a regular expression. Its language is a set of W such that W contains a single, you know, only one, O-N-E, and only one. It's a bit confusing. Okay, what about this one? This is an alphabet, capital sigma, and we're told before these examples that sigma is the binary alphabet, 0 and 1. Okay? So sigma star, that's just a binary string of zeros and ones. Okay? And then concatenated with a 1 in the middle, and similar here, another arbitrary binary string or set of. So what language is this describing? The set of what? Set of W's such that W has at least one 1. It has one, you know, O-N-E, and has one in it. Right? How about this one? Well, this is a set of strings that has 0, 0, 1 as a substring. Hope that's fairly clear. Right? So here's your regular expression, and here's the language that regular expression describes. Okay? So it's the set, because that's what a language is, just a set of strings. Okay? So it's a set of strings W, such that W contains the substring 0, 0, 1. How about this one? Now pay attention, you've got a plus here. Okay? Now what does this mean? That's not so obvious, right? So 0, well, forget about the star for the moment. Just concentrate on the 0, 1 plus. What does that mean? Now plus is almost like star, okay? Except you cannot have the plus is a set of concatenated strings, but with the plus you cannot have the empty string. Right? So here, if you have a 0 here, you must have a 1 after it. Can you see that? You can't have a 0 after this first 0. You cannot have a second 0. Why not? Well, because 1 plus, and that set is all concatenated strings of 1s, but the length of the smallest string in that 1 plus is 1. So your strings would be 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, and so on. Right? So the description then of these strings would be it's strings wherever you've got a 0 in the string, it's followed by a 1. So every 0 in your string is followed by at least 1 1. Okay. All right. This fifth example. So what are we doing here? Now it's the binary alphabet. Okay. Here. And we're concatenating the two. So what's going on? So it's the binary alphabet. So if you the length of each string in the alphabet is just 1. Okay? And you can concatenating it with the same sigma. So what would this set you forget about the star for the moment. What would this set be like? What would it contain? Well, it'd be either 0, 0, 0, 1, 1, 0, or 1, 1. Okay? So that's the set of these, the four strings in that sigma. And then you star it. Well, can you see that it would be the set of strings that are of even length? Does that make the length of these strings in this set are described by this regular operator. They all have length that is even. Right? Well, we've done it a bit before, but just a reminder here, like a note. The length of a string, what does that mean? So 3 bars by definition. Well, it's the number of symbols in the string. And that's all pretty simple. So, change camera.